Our place in space. Latitude and longitude explained. Imagine Earth as a giant ball floating in space. How do we find our way around on this massive sphere? We use a system of imaginary lines called latitude and longitude. These lines create a grid system that helps us locate any point on Earth's surface. Latitude lines run horizontally around the Earth, parallel to the equator. They tell us how far north or south a location is from the equator. Longitude lines, on the other hand, run vertically from the North Pole to the South Pole. They tell us how far east or west a location is from a line called the prime meridian. Think of it like reading a map. Latitude lines are like the horizontal lines on a map, and longitude lines are like the vertical lines. Just like a grid reference on a map helps you pinpoint a specific location, latitude and longitude coordinates give us an exact address for any point on Earth. Lines on a globe measuring Earth's grid. Latitude and longitude are measured in degrees represented by the symbol degree. Each degree is further divided into 60 minutes and each minute into 60 seconds. This system allows for very precise measurements on Earth's surface. Latitude lines are numbered from 0 degrees at the equator to 90 degrees at the north and south poles. Locations above the equator have north latitudes, while locations below have south latitudes. For example, Sydney, Australia is located at approximately 34 degrees south of the equator. Longitude lines are numbered from 0 degrees at the prime meridian to 180 degrees east and west. Locations east of the prime meridian have east longitudes, while locations west have west longitudes. For example, London, England is located at approximately 0 degrees longitude, while New York City, USA is located at approximately 74 degrees west longitude. By combining the latitude and longitude coordinates, we can pinpoint any location on Earth with incredible accuracy. For instance, the Sydney Opera House in Australia is located at 33 degrees 51 minutes 31 seconds south, 151 degrees 12 minutes 40 seconds east. 0 hour, 0 degrees, the equator and prime meridian. The equator and the prime meridian are two special lines in our system of latitude and longitude. They act as the starting points for measuring distances east-west and north-south. The equator, as its name suggests, divides the Earth into the northern hemisphere and the southern hemisphere. It's an imaginary line that circles the Earth at 0 degrees latitude, exactly halfway between the north and south poles. The equator is significant because it receives the most direct sunlight, making regions near the equator generally warmer than those closer to the poles. The prime meridian, on the other hand, is a line of longitude that runs from the North Pole to the South Pole, passing through Greenwich, England. It's designated as 0 degrees longitude and serves as the reference point for measuring all other longitudes. The prime meridian divides the Earth into the Eastern Hemisphere and the Western Hemisphere. Section 4. Finding our way. The importance of coordinates in navigation. Latitude and longitude are essential for navigation, whether we're sailing across oceans, flying through the air, or simply finding our way around town. These coordinates provide a common language for locating and communicating positions on Earth. Before the advent of modern technology like GPS, sailors relied on celestial navigation, using the positions of the sun, moon, and stars to determine their latitude and longitude at sea. By measuring the angle of the sun at noon, or the position of certain stars, they could calculate their distance from the equator and the prime meridian, allowing them to navigate vast distances with remarkable accuracy. Today, GPS technology uses a network of satellites orbiting Earth to provide precise latitude and longitude coordinates to receivers on the ground. This technology has revolutionized navigation, making it easier than ever to find our way around. From car navigation systems to smartphone apps, GPS relies on latitude and longitude to guide us to our destinations. Section 5. Latitude and longitude in action, from exploration to everyday life. Latitude and longitude extend beyond navigation. They are crucial in cartography, geography, geology, and climate science. Map makers use them to create accurate maps. Geologists study plate tectonics and locate resources. Climate scientists track weather and study climate change. In everyday life, they power location-based services. From ride-sharing to weather apps, we rely on these coordinates. Latitude and longitude connect us to a global grid, essential for exploration and technology.